So the whole setup of the problem is that you needed three different areas that matched certain criteria, such as this one had to be twice of the first one, and the third one had to be 3 times the second one in terms of area. So your area formulas are being added up. The first box, the second box, and then the third box, all simplify to 9xy. Your perimeter, this is the perimeter for the first one, for the second one, and for the third one. And that all simplifies down to 6x plus 18y. And then from there, you're going to have to set the 6x plus 18y equal to 10,000 because that's how much feet in fence he has to work with. And always simplify, as our group study learned yesterday in 6th period. The larger you leave the numbers unnecessarily, the more problems you will have later. So 5,000 minus 3x over 9 is the simplest form of y. So over here, you're going to end up with that value plugged into your area formula. Remember 9xy. So here's the y that we solved for. Dwindle it down and then get a derivative. Set that derivative equal to 0 and you come up with 833 1/3. Then the second derivative is simply -6, so that's a max. So with this number you go back and plug it into the perimeter formula and you can solve for y, which is this. To use calculus to solve optimization problems, here's an example of the right triangular prism problem. A right triangular prism has an isosceles base, and from the Wizard of Oz you should know that that means 2 sides are equal. The Scarecrow mentions that at the end, or some similar formula. A right triangular prism has an isosceles base. So there's a right triangular prism. You can do your best to draw that three-dimensionally. If it's right, then it has a right angle, and you're going to have 2 sides that are congruent for the triangular bases. Now the prism is to have a volume of 4,800 feet. 4,800 feet for the volume. What dimensions will yield the least materials to make the prism? Looking for the least amount of materials. So here's a question. What is the formula for the volume of a triangular prism? In general, it's 1/2 base times small height and then times the large height, with the small one being the one with the triangle and this one being the one with the prism, the height of the prism. But we're going to use x and y, like she said. So label the prism with x and y. So there's an x, there's a y. Now remember, you have an isosceles base, so you have 2 x's on the triangle. They're both the same. The formula, when you write it out, should be 1/2 base times height, but in this case it's x times x. And then you have a y in there. So 1/2 x squared y would give you the volume of the triangular prism. So what is the surface area of a triangular prism? First, you're going to need the surface area of a triangular face. You should know the area of a triangle is 1/2 base times height. But in this case, it's 1/2 x times x. So in general, it's going to be 1/2 x squared. But you have 2 of them. You have one in the front, you have one in the back. So 1/2 x squared plus 1/2 x squared is going to give you the area of both bases together. But you can simplify that to simply x squared. If you have 1/2 x squared plus 1/2 x squared, that is just 1 x squared. So what is the area of the underneath, the way it's lying now, the underneath of the triangular prism? XY. Simple as that. What we have so far is the following, and we'll build on to this until we have it all. We have x squared plus xy. That's the two bases and then one of the sides. What is the area of the left-hand side, the back side? XY. And this is what we have so far. X squared plus xy plus xy. That's the same thing as x squared plus 2xy, and always simplify and combine like terms in this. Otherwise you end up with equations that are way out there. Now what is the slanted side in terms of surface area? Clearly one side of it is going to be y, but the other side, you have to find the hypotenuse of this triangle, which would be this slanted side, in order to multiply that by y to get the area of the slanted side. So the hypotenuse would equal hypotenuse squared equals x squared plus x squared. That's just a variation of the Pythagorean theorem. And then you have to go through and simplify that. So hypotenuse squared equals 2x squared. And then you need the square root of both sides. And you come out with hypotenuse equals 2x squared, but you can simplify this and it will make it easier later on. You can apply the square root of 2x squared to finding the area of this side, and we'll simplify that when we get to it. So now what's the area?
Y times the square root of 2x squared.
That's right. Y times the square root of 2x squared. Now simplify that part now. You have the square root of 2 and then square root of x squared. If you break them apart like that, you can find the square root of x squared, and that would simply be x. So that simplifies down to xy square root of 2. And that's what we'll plug into the remainder of the surface area formula for the whole prism. So here's what we have so far. Surface area equals x squared plus 2xy plus xy square root of 2. So that's the final formula. And here's what we have all together for the whole problem. You have a volume that's 1/2 x squared y, and then surface area is x squared plus 2xy plus xy square root of 2. Now the volume must be 4,800. Therefore, 1/2 x squared y equals 4,800. And solve for y. So there's the initial formula. And divide 4,800 by 1/2 x squared. But you can simplify that division by 1/2 by multiplying by what? Yeah, so if we multiply by 2 on the top, we end up with 9,600 over x squared. So substitute 9,600 over x squared for y in that surface area formula. So there's the surface area formula on top, and I've gone through and put in 9,600 over x squared every place you see a y, and that's only 2 places. So you're going to have it here and then here. Then we have to go back and simplify the best we can. So you're going to have to multiply in here the 2 times 9,600. There and there, that's where the 19200 comes from. And notice there was an x over x squared in there. That cancels out to just x on the bottom. And then that's the same deal here. X over x squared cancels out the x on the bottom. Find the first derivative. So there's the surface area function. And the first derivative, remember the rules. Exponent down in front, reduce the exponent by 1. Increase this exponent by 1, change the sign out here, and multiply the top by the old exponent, which was 1. So you're still left with 19,200. And then here on the back end, change the sign, increase the exponent by 1, multiply the top by the old exponent, which was 1, so it stays the same. Now that we have it in the first derivative form, what do we do next? Yeah, we got to set that equal to 0. So there's the first derivative, and there it is set equal to 0. What can I do to make this much easier to solve? Yeah, multiply by x squared to get rid of those denominators. So that's what we're going to do. And we can cancel those out and make an adjustment there for the 2x. You end up with 2x to the third minus 19,200 and then minus 9,600 square root of 2. All of that equal to 0. That's much easier to solve. So now to get your answer, you're going to have to divide 19,200 plus 9,600 square root of 2 over 2. Divide it by 2, that is. Remember, when you move these to the right, they become positive, and divide by this 2. So you should get an answer of 25.4006 when you round to 4 places. But first, you have to find the second derivative. We have to verify that this is actually going to be something that we can use. Alright, so there's the first derivative, and there is the second one. Remember, for this, you just keep the 2. But here, you got to change the sign again. Increase this exponent by 1, and multiply the top by the old exponent. That's where we get 38,400. It's this times 2. And then back here, change the sign again, increase the exponent by 1, and multiply this by the old exponent. 19,200 square root of 2. And then evaluate it for 25.4006. Is it plus or is it minus? Is the final answer of that going to be positive or negative? Yes, it's going to turn out to be positive. And it says the answer is 1. Actually, that should be. Answer is positive. So there we go. We have the minimum there. So 25.4006 is a minimum value. And insert 25.4006 into 1/2 x squared y equals 4,800 and solve for x. Or actually, you're solving for y. You're plugging it in. Plugging it in for x, and you're solving for y. So there's the formula. Plugging it in. Divide 4,800 by 1/2 times the quantity squared of 25.4006, and you should get 14.8793.